theoretical maximum voltage on an industrial always-powered fire alarm circuit depends on the National Electrical Code, or NEC, requirements and the specific fire alarm system design. However, it is generally limited to 30 volts alternating current or 60 volts direct current. An industrial always-powered fire alarm circuit would be classified as a Class 1 circuit. This is because it is a circuit that is used for the transmission of signals relating to the detection of fire or smoke. Class 1 circuits are required to have a level of protection that ensures the reliability and integrity of the signals transmitted on the circuit. Some fire alarm systems may utilize higher voltages, such as 120 volts alternating current or 240 volts alternating current for power distribution. However, the actual voltage on the fire alarm circuit itself is typically limited to values below 30 volts alternating current or 60 volts direct current. The NEC also requires that fire alarm circuits be isolated from other electrical circuits to prevent interference and ensure proper operation in the event of a fire. Fire alarm systems are critical life safety systems designed to detect fires early and alert occupants, allowing for safe evacuation. Understanding the electrical characteristics of these systems, including voltage limitations and circuit classifications, is crucial for proper installation, maintenance, and troubleshooting. The NEC provides comprehensive guidelines for fire alarm systems covering aspects such as wiring methods, overcurrent protection, grounding, and supervision. These requirements are intended to ensure the reliability and functionality of the system under various conditions, including power outages and fault conditions. The voltage limitations on fire alarm circuits are primarily intended to minimize the risk of electrical shock and fire hazards. Low-voltage circuits are inherently safer than high-voltage circuits, reducing the potential for injury to personnel who may come into contact with the wiring. Furthermore, low-voltage circuits are less likely to cause ignition in the event of a short circuit or ground fault. The classification of fire alarm circuits as Class 1 circuits reflects the importance of these circuits for life safety. Class 1 circuits are defined as power-limited circuits that operate at voltages up to 60 volts direct current or 30 volts alternating current and have a maximum power output of 100 volt amps. These circuits are required to be installed in accordance with specific wiring methods and protection measures to minimize the risk of fire or electrical shock. The isolation of fire alarm circuits from other electrical circuits is another important safety measure. This isolation prevents interference from other electrical equipment that could compromise the operation of the fire alarm system. For example, a surge on a power circuit could potentially damage the fire alarm control panel or cause false alarms if the circuits are not properly isolated. There are several types of fire alarm circuits that may be found in an industrial facility. Some common examples include initiating device circuits, notification appliance circuits, and signaling line circuits. Initiating device circuits connect fire detection devices such as smoke detectors, heat detectors, and manual pull stations to the fire alarm control panel. Notification appliance circuits connect audible and visual alarm devices such as horns, strobes, and speakers to the fire alarm control panel. Signaling line circuits are used to communicate between the fire alarm control panel and remote devices such as annunciators and remote control units. Each of these circuit types has specific electrical characteristics and wiring requirements that must be followed to ensure proper operation. The design and installation of fire alarm systems should be performed by qualified and experienced professionals who are familiar with the NEC and other applicable codes and standards. These professionals can ensure that the system is properly designed, installed, and tested to meet the specific needs of the facility and to provide reliable fire protection. Regular inspection and maintenance of fire alarm systems are also essential to ensure their continued reliability. These inspections should be performed by qualified technicians who can identify and correct any potential problems before they become major issues. The inspection should include testing of all initiating devices, notification appliances, and control panel functions. In addition to the NEC, there are other codes and standards that may apply to fire alarm systems in industrial facilities. These include standards from organizations such as the National Fire Protection Association or NFPA and the International Building Code or IBC. These codes and standards provide additional guidance on the design, installation, and maintenance of fire alarm systems. The specific requirements for fire alarm systems may vary depending on the occupancy and the type of hazard present in a facility. For example, a facility that handles flammable materials may require a more sophisticated fire alarm system than a facility that does not. It is important to consult with a qualified fire protection engineer to determine the appropriate level of fire protection for a particular facility. In summary, the theoretical maximum voltage on an industrial always-powered fire alarm circuit is typically limited to 30 volts alternating current or 60 volts direct current, and these circuits are classified as Class 1 circuits. The NEC provides comprehensive guidelines for the design, installation, and maintenance of fire alarm systems, and these guidelines should be followed to ensure the reliability and functionality of the system. Regular inspection and maintenance are also essential to ensure the continued reliability of the system. Always consult with qualified professionals for fire alarm system design, installation, and maintenance. Understanding the requirements related to voltage limitations, circuit classifications, and isolation is paramount for ensuring the safety and functionality of these life safety systems. The purpose of limiting the voltage in fire alarm circuits is twofold. Firstly, it reduces the risk of electrical shock to individuals who may come into contact with the wiring, and secondly, it minimizes the potential for ignition in the event of a short circuit or ground fault. The use of lower voltages inherently makes the system safer in these respects. The classification of these circuits as Class 1 circuits mandates that they adhere to specific wiring methods and protection measures. This is to further reduce the risk of fire or electrical shock. These measures include using appropriate wire types, conduit, and overcurrent protection devices. Isolation of the fire alarm circuits from other electrical circuits is critical to prevent interference that could compromise the system's operation. This isolation is typically achieved through physical separation of wiring, the use of isolation transformers, or other approved methods. The different types of fire alarm circuits found in industrial facilities, such as initiating device circuits, notification appliance circuits, and signaling line circuits, each have their own specific electrical characteristics and wiring requirements. These requirements are detailed in the NEC and other relevant standards. Proper design and installation of fire alarm systems must be performed by qualified professionals who are well versed in the NEC and other applicable codes. These professionals can ensure that the system is designed and installed in accordance with all applicable requirements and that it meets the specific needs of the facility. Regular inspection and maintenance are crucial for ensuring the continued reliability of fire alarm systems. Inspections should include testing of all components, such as initiating devices, notification appliances, and control panel functions. Any deficiencies identified during inspection should be promptly corrected. In addition to the NEC, other codes and standards such as those from NFPA and IBC may apply to fire alarm systems in industrial facilities. These codes and standards provide additional guidance on the design, installation, and maintenance of fire alarm systems. The specific requirements for fire alarm systems may vary depending on the occupancy and hazard level of the facility. A qualified fire protection engineer can help determine the appropriate level of fire protection for a particular facility. To reiterate, the typical voltage limits for industrial fire alarm circuits are 30 volts alternating current or 60 volts direct current, and these circuits are classified as Class 1 circuits. Adherence to the NEC and other applicable codes and standards is essential for ensuring the safety and reliability of these critical life safety systems. The NEC guidelines cover a broad spectrum of requirements, extending from wiring methods and overcurrent protection to grounding and supervision. These elements are crucial for ensuring system reliability under various conditions, including power outages and fault conditions. The 30-volt alternating current or 60-volt direct current limitations are not arbitrary. They are carefully chosen to mitigate the risk of electrical hazards. These lower voltages reduce the possibility of electrical shock and also decrease the likelihood of ignition in the event of a short circuit or ground fault. The Class 1 designation is not merely a label, it signifies that the circuit must adhere to stringent wiring methods and protection protocols. These protocols include using appropriate wire types, proper conduit, and suitable overcurrent protection devices. Furthermore, the NEC mandates that fire alarm circuits be physically and electrically isolated from other electrical circuits. This isolation is pivotal in preventing interference that could trigger false alarms or, worse, compromise the system's ability to detect an actual fire. The various types of fire alarm circuits commonly found in industrial settings, such as initiating device circuits, notification appliance circuits, and signaling line circuits, each come with their own unique electrical characteristics and wiring stipulations. These stipulations are rigorously detailed in the NEC and other pertinent standards. The responsibility for designing and installing these systems should be entrusted to seasoned professionals who possess an in-depth understanding of the NEC and other relevant codes. These experts can guarantee that the system is not only designed but also installed in full compliance with all applicable requirements, meeting the facility's specific safety needs. Regular inspection and maintenance are not optional extras, they are fundamental to maintaining the long-term reliability of fire alarm systems. These inspections encompass thorough testing of all system components, from initiating devices to notification appliances and control panel functions. Any deficiencies discovered during these inspections must be rectified without delay. Moreover, it's essential to be aware that in addition to the NEC, other codes and standards, such as those promulgated by NFPA and IBC, may also apply to fire alarm systems within industrial facilities. These additional guidelines offer further insights into the design, installation, and maintenance aspects of these critical systems. The specific requirements for fire alarm systems can differ significantly depending on the nature of the occupancy and the potential hazards present in the facility. Therefore, seeking advice from a qualified fire protection engineer is often necessary to determine the optimal level of fire protection for a particular setting. To summarize, the maximum voltage allowed on an industrial fire alarm circuit is generally 30 volts alternating current or 60 volts direct current, and these circuits fall under the Class 1 designation. Compliance with the NEC and all other applicable codes and standards is non-negotiable for ensuring the safety and unwavering reliability of these life-saving systems. Regular inspections and maintenance should be regarded as essential practices for sustaining the system's ongoing reliability and effectiveness. Always engage qualified professionals for all matters related to fire alarm system design, installation, and maintenance. Their expertise is critical in ensuring that the system functions as intended, safeguarding lives and property. Understanding the nuances of voltage limitations, circuit classifications, and isolation techniques is paramount for anyone involved in the management or maintenance of industrial facilities. This knowledge contributes to a safer and more secure environment for all occupants. For example, consider a manufacturing plant that uses robotic welding equipment. The plant's fire alarm system must be designed to account for the potential fire hazards associated with welding, such as sparks and hot metal. The system might include heat detectors in the welding area, as well as a suppression system to extinguish any fires that do occur. The fire alarm control panel would be programmed to activate the suppression system automatically in the event of a fire. Or take a chemical processing plant that handles flammable liquids. The fire alarm system in this type of facility must be designed to detect and respond to flammable liquid fires. The system might include flame detectors in the storage and processing areas, as well as a foam suppression system to extinguish any fires that occur. The fire alarm control panel would be programmed to activate the foam suppression system automatically in the event of a fire. In both of these examples, the fire alarm system is designed to protect life and property by detecting and responding to fires quickly and effectively. The system's design must take into account the specific hazards associated with the facility, as well as the applicable codes and standards. When inspecting a fire alarm system, there are several things that a technician should look for. Firstly, the technician should check the system's documentation to ensure that it is up to date and accurate. The documentation should include a list of all system components, as well as a wiring diagram and a description of the system's operation. Secondly, the technician should visually inspect all system components to ensure that they are in good condition and that they are properly installed. The technician should look for any signs of damage, such as broken wires or corroded terminals. Thirdly, the technician should test all system components to ensure that they are functioning properly. The technician should test the initiating devices, such as smoke detectors and heat detectors, to ensure that they are able to detect a fire. The technician should also test the notification appliances, such as horns and strobes, to ensure that they are able to alert occupants of a fire. Fourthly, the technician should check the fire alarm control panel to ensure that it is functioning properly. The technician should check the panel's display to ensure that it is showing the correct information. The technician should also check the panel's batteries to ensure that they are fully charged. Finally, the technician should document all of the findings in a written report. The report should include a list of all the items that were inspected, as well as any problems that were found. The report should also include recommendations for how to fix any problems that were found.